Alrighty, let's get started. So we are now in week 7, and next week we're going to do the midterm. And what's going to be on the midterm, don't worry, it's a take-home midterm, is going to be everything that we covered up to this point. Okay, so that means you need to know functions, you need to know the loops, selection, ifs and elses, else ifs, for loops, while loops, do while loops, all that good stuff, right? Input and output, formatting your output, making random numbers. So those are the things you should be comfortable with. And what I'm going to do is I'm just going to start with the notes that I had from question.
You said it's midterms. Do we have to be here to take them?
You don't have to be here to do the midterm. You can do it from home entirely. Yeah, it's just basically like another one of these assignments. It's just worth more points. Question?
So we're having a lecture that day, or?
No, we're not having a lecture that day.
What are the rules for the midterm?
Rules are do it by yourself.
Okay. But can we look at all the assignments, or?
You can look at all. Yeah, you're welcome to look. It will be open notes, open books. So you're welcome to look at everything you've done up to that point. Yeah, just use all your previous programs as reference. Look at them, and yeah.
We don't have a time limit on them, right?
There's no time limit. Just like any other assignment, just try to turn it in as early as possible, because I also offer a regrade on the midterm. And by the way, if for whatever reason you want to check with me before you turn in the midterm, that's okay too, right? That way I don't, get the thing and I have to take points off and then explain to you what's wrong with it, and then you have to resubmit it. It saves me work if you ask me in advance, does this look good? And I say yes, then you're good. Okay? So, question?
Does it have to work, the program? Do we have to test it, or do we just write it and say this is what
You
it
have to
looks
test
like?
it. Yeah,
We
you
have to test it.
just like any other program. You gotta
Same format?
same format like any other program. You comment on top what you did, show me the program worked. If it doesn't work, yeah, if you didn't test it, we're gonna have a problem, right? I'm gonna take some points off, just like any other assignments. We're good? Any other questions? Yeah.
I'm sorry, because I think you already said it, but I just want to ask. So if we are having trouble with our program, we can ask?
If you have problems with the programs on the midterm, you're very welcome to come and ask me. Yeah, just before you submit it, if you want to double check with me that it looks good, email it to me and I'll let you know. Okay? So no reason not to get an A on this thing. So, and if for whatever reason you don't want to do that and you turn in the thing and let's say you bombed it, you got a 50% on the midterm, then I will offer a regrade for that, but it's not for full points. Like all the other assignments for the midterm, I offer 50% back. Right? So you turn it in, you got a 50, that means that, if you fix it and resubmit it, you're going to go from 50% to 75%. Okay? So are you still okay? All right, so and that's why if somebody's procrastinating and just waiting for this to just turn in the work in the last minute, like it happened in the summer. I have one student who's really good. He's like the vice president of the club, and he turned in all his freaking work in like the last 2 days of class, and he didn't have a chance for a regrade. Okay, and if I wasn't extremely nice, he would have probably not gotten an A in the class. All right, but anyway. So so those are the rules for the midterm, just like any other assignments. Make sure that your works, test it, ask me in advance if you want, all that good stuff. Use your old programs as a reference. Use the book, use the PowerPoint. Try not to Google things, right? So use things that we learned in the class, okay? And if you're going to be using something else, I expect comments and explanation of what it is, how you did it, and why, okay? So that's that. All right, so functions. Let's go and look at what I told you last time about functions. And by the way, you're welcome to look at the lecture notes and the videos for the Thursday class too, because I might cover some things in one of them that I didn't in the other one. They should be mostly the same though. So C-line. Let's see what we did. So I talked to you about the different kinds of variables, right? What's a global variable? It is a variable that's declared before and outside all the other functions, which means that you can use it in any of the other functions. You can change it, you can show it in any of the other functions. Okay, that's what's a global variable. I discourage, in fact, I don't want you to use these, right? No global variables in this class. We're only going to be using local variables, right? And what were the local variables? Well, parameters are an example of a local variable. What's a parameter? Parameter is a variable which is defined inside of the parentheses of a function. Okay. We also had local variables that are defined inside of the functions, like C, for example. Here, it's declared inside of the main function, so it can only be used inside of the main. Okay. Or the scope of the variable is the main. Okay. So the scope refers to where a variable can be used. The scope of a variable is where it was declared. If you declare it in a function, it can be declared. It can be used in that function. So the scope of that variable, the scope of variable C is which function? Main. Okay, right. And the scope of variable num is which function? Function A. Okay. So that's where it can be used. That's where it can be changed. That's where you can show it. All right. So these are the different kinds of variables, and again, variables that are defined inside of the parentheses of a function, they're called parameters. Okay, so now going to the functions, right? What's a function? Well, it's like a variable with some parentheses after it, basically. Okay, functions are ways to group and reuse your code. This particular function here is called stars, right? That's the name of my function. Void is the return type. It means the function is not going to return any value. Okay, you could have just a return in the function with nothing in it. And if you have just a return with nothing in it, that is basically how you tell it to exit the function, right? It's like break inside of a loop. Okay, this function here, that function returns an integer. The function name is return1. The function does not have any parameters. Okay, you can have different kinds of return values. You can have an integer, you can have a character, you can have a string, a float, a double, right? All the basic data types you can return. This one here, all right, the function name is showNum. This one here is the parameter, which is an integer. The parameters, again, just like the return type of a function, can be of all the different data types. It could be a character, it could be a string, it could be a boolean. Could be, any of the other ones, floats, doubles, long, okay? And by the way, anyone remember what a long is in any of these examples, maybe? What's a long? Yeah, really, really, really long integer. That's a long, okay? Same kind of thing like a double, right? What's a double? What's like a longer float? Okay? All right. So then I have another function in here. This one's called sum, right? It's got two parameter variables. They're both doubles. The function returns a double. All right. Okay. So let's look at some of this other stuff. So this here, this is calling the function, right? So my function is called stars, right? And how you call that function? You just put the function name. You do not put void in front, right? You just put the function name, parentheses, and semicolon. Right? That's your function call. As soon as you execute the function call, or whenever you have a function call statement, you're going to jump to the function definition and execute everything that's inside of the function definition. So the format that I was telling you to use is you're going to have your prototypes on top, right? These are all the prototypes. You're basically declaring what the function is going to be like, and then you have your function calls. Usually in the main, functions can call other functions, and then this is your actual function definition, right, under the main. Okay, so all the definitions are under the main, all the prototypes are on top of the main, and in the main is where we're going to call a whole lot of them. Okay, so this is my function stars. As soon as I call the function inside of the main, I'm going to execute everything that's inside of the curly brackets. Every time I call the function, I execute everything that's inside of the curly brackets. Okay. Then there was an example here of a function that returns a value. So this is an example of a function that shows some things. It has a bunch of couts. And how do we call a function that has a bunch of couts? Well, you just call it, right? This is your function. As soon as you call it, it's going to execute a bunch of couts. You want to call it again, no problem. It's going to execute a bunch of couts, right? But now here is a function which returns a value. And what I showed you was that if I call the function like this, nothing's going to show, right? Why? Well, because return 1 just returns the value of 1. You're going to bring back that 1 wherever you call the function. And if there's no cout or anything, nothing is going to show, right? So this here basically just brings the number 1. And are you going to see that 1? No. So that's why it doesn't show. Okay, if you want to see it, show it, call the function from inside of a cout. If you want to store the variable or the value that this function is returning, make a variable equal to the function call, right? That way this function is going to go, we're going to go to the function, we're going to execute the return 1. 1 is going to come back where we call the function. Now this thing is equal to 1 and we can use that value for something else. Okay? The next thing that I showed was calling a function that has a parameter, all right? And that is showNum right here. That's the first one, all right? So the showNum has one integer parameter, which means that when we're calling the function, we have to put some kind of an integer inside of the parentheses of the function call, right? That value that we're putting in between the parentheses is called the argument. Okay, as soon as we call the function, we're going to pass the value or the argument into the function, and then, so this is 10, and then num is going to be equal to 10, and then we can do whatever we want with that value num, of num. Alright, so where's my function showNum? Here's showNum, right? So as soon as I call this thing with showNum10, right, then this here becomes equal to 10, and then I'm going to show you 10. So whatever value I put as an argument in my call, that is what this parameter variable is going to be equal to. Okay, I can put values, right? That's an argument, different kinds of values, right? Or I can put a variable, right? This is the variable a. I'm putting a in between the parentheses. Now a is my argument, which is the same as, so this one right here, shownum a is the same exact thing as just showname 100. You're just passing the value into the function. And one thing that I'm going to show you today is passing by pointers, right? So this right now, what I showed you was pass by value. Today I'm going to show you pass by pointer, which is a whole new animal. But we'll get to it when I get to it. So next one is sum. So it's another function which is going to return, what is the sum? Sum return is a double, and what are we going to be doing? We're going to be adding two values most likely, right? Where's my definition for sum? Sum is right here, right? So we have parameter A, parameter B, we have some variable, local variable total, which is equal to A plus B, and then we're going to return total, right? Or I could have just simplified this whole thing on top with just saying this, right there, okay? So same thing. And when I call my function, which is here, I'm sending two values that the user has entered, okay? So that was calling a function which takes parameters and returns a value, okay, or takes arguments and returns a value. Then I went on to explain to you the different, how, let's say for example you have a variable b which is inside of my main, that's a local variable b, and then I went and I defined a function pass by value. Pass by value is right here, alright? So it's just like any of these other ones, just it's exactly like this first function that I showed you. It just has a parameter variable. This one's called b. Okay, so in here when I call the function, well, before I call the function I said, all right, let me show you the memory address of b here, and I did a cout and I did an %b, right? %b is how you show a memory address in C++, and I'm going to show you how to work with this today and how to use it for something actually useful. So the memory address of b, if I run it, it will likely be a different number because every time I run the program, things kind of get rearranged in memory based on what other programs were running before it, right? If I restart my computer, it will change again, right? If I run my computer for a long time, it will change because my program is not going to always be running in that one fixed place in memory. So anyway, when I show you the memory address of B, it will be something like this, right? Some kind of a long hexadecimal number. This one ends with an AC4, right? And then what I did is I showed you the value of B. So B starts at 99 here, and I show you the value of B, which is 99. Then I do a pass by value. I do a B, right? And just like the function name states, we're passing the value of B, right? We're not passing the variable B itself. So pass by value B, let's see what it does. Where is it? Where is it? Pass by value B. Okay, so this is my B parameter, right? And then the first thing I do in here is I say B is equal to 0. Okay? And even though I'm changing B to be equal to 0 inside of my function call, right? If I show you the value of B before and after, you're going to see that the B here stays equal to 9 or 99, right? And the reason for this is because this B here, which is in the main, is different than the B which is in my function, right? And I showed you that both of these, or these two different variables, they have different memory addresses. So this one in the main had a memory address of AC4, and the other one in my function and pass by value had a memory address of A3C. So these two different these two variables which have the same exact name are actually referring to different places in memory, which is why if I changed B in here, I'm not changing the B in the main. They're two different B's. Okay? So that was the point, that if you're sending a variable, if you're passing a variable in by value as an argument, you're not going to be able to change it if you're doing it this way. And today I'm going to show you how you can change it. Okay? All right. So that's that. And then there was like some examples here of local variables, how you can have a local variable inside of an if, right? Any block of code that has its own curly brackets, if you define a variable for that block of code, it will be local to that block of code, and you will not be able to use it outside of it. Okay? So function B and function B. Okay, function B, the moral of the story for function B was why you want prototypes, right? And the reason why we want prototypes on top of the main is because you want to basically define your functions in any order that you want underneath the main, right? So if I don't have my prototypes, let's go look at functions A and B. Right? Function A, function B. So if I did not have the prototypes, I would not be able to do this, right? What's happening here is I have function B, right, which calls function A, but function A happens to be defined after function B. So if I did not have the prototype to tell the program A there is a function A, this is not going to work, okay? Because as soon as I get to line 169, the program will not know what follows, which is the function A defined in lines 172 through 175. Okay, so that's the reason why we have prototypes. Okay, because you want to define these functions in any order that you want, and so that they can see each other. Okay, any function can see any other function and work with it. Okay, so that was the purpose of these two functions that I had in here. So then what I do is, and it was also an illustration of how one function can call another function, right? So if you see that in here, this is my main function. In the main, I call this function, function B, and then function B in turn, right? This is my function B calls my function A, and then function A does something else. And that's what happens. A lot of times you have a whole bunch of different functions calling each other all over the place and, accomplishing something. So next, I just gave you a bunch of hints for the assignments. Any questions about any of this stuff? We're good? Sure? Positive? Okay. All right. So let's see if I have anything else here for today that I have on the webpage to mention to you. Yeah, pointers. Okay, so today I have a few assignments, a bunch of assignments. And by the way, I don't know if you tried it already, but a lot of these function assignments, they're not very hard. They're not very time consuming. If you understand functions, you know, these assignments are going to be some of the easiest ones in the class, I guess. Okay, so for this week, I have 3, 6, 7 assignments, and then 2 more extra credits. Okay, I didn't have these as extra credit before, but now they're extra credit. So you're welcome. 46 and 47. Okay, both of these are a little bit challenging, so I guess I'll show you a little bit of it. So let me look at. I'll let you read the chapter 5 Savage with probably 100 pages worth of stuff about parameters and pointers, and I'll give you the short version. And then I'm going to tell you about these prime numbers, which ties with this assignment, and then also the show stars. Okay, so pointer variables. Let me just, what I'm going to do is, let me erase a bunch of this stuff. Except this piece here. Okay, so I'm leaving only pass by value b, and I'm going to erase all these other ones. Pass by value b, you are there. Okay. So all I have is pass by value. Okay? So what I'm going to do is, now I'm going to show you how you can change the value of b from inside of a function. Okay? And that's one of the reasons why I don't want you to use global variables, because if you know how to do this, you don't need global variables. Okay? So what I'm going to do is, I'm going to create a function called void pass by pointer. Okay, and I'm going to do int b. I'm not even going to call it b. I'll call it d. Right? Asterisk d. Okay, so asterisk d means that this is going to be an integer pointer. Okay, what is a pointer? Pointer is a variable which is equal to the memory address of another variable. That's the entire purpose of a pointer variable. Okay, it's not going to be equal to some value like 10. It's not going to be equal to like a character A or whatever. It will be equal to the memory address of some other variable. And by the memory address, I mean this, the %b, this weird long number, you know, whatever that number is. So that's the whole purpose of that variable. Okay, so I guess what I'm going to do is I'm going to show you an example here of how that works. All right, and I actually have more of this in a later week, I think. Let me see, go to week 8, no, 9, pointer example, yeah, in week 9, so I guess I'm kind of warming up earlier with this stuff. It's in the week of after the midterm, which is, yeah, so I'll show you basically this example right here. Okay, so let's say I have an int a. Okay, this is my integer variable a, and I'm going to comment out this stuff here for now. Okay, so I have an int a is equal to 1. Okay, and I can show you it. A equals a and l. Right, this is the value of a. Okay, and then if I do cout, ampersand a equals ampersand a, then this is your memory address of a. Okay, so if I run this thing, not there. All right, there's your memory address of a. Okay, so if I run it multiple times, hopefully same address stays. Yeah, except the font size goes down. All right, so that's a memory address of a. So then what I'm going to do is, what did I use here? Big A. Okay. Got a big A somewhere? No. Okay, so then what I'm going to do is I'm going to say int asterisk A. Okay, and what do we say this is? This is a pointer variable A. Okay, and if I do a cout for this, cout A equals, let's see what that's equal to. Even though that's going to be weird because it's not, I mean, I don't know what a garbage pointer value will look like, but we'll find out. Nothing. Okay, so I'm assuming it's equal to null. Okay, so what this is it's a pointer. Okay, and I suppose by default the pointers in C++ are equal to null. What is a null? Well, if you notice, my email is null dreamer, so that's where it's coming from. Now you know. Okay, so it's like a pointing to, you know, it's a pointer that points to nothing is a null, basically. Okay, it's like making it something equal to 0. Okay, so instead of making a variable a equal to 0 initially, you're making it equal to null. Okay.
On the C out line below it, you don't actually have
Null.
the A outside of the quotes before the end.
Ooh, thank you. I just keep talking. Let's see what it's equal to. Good point. So it is not null. I take it back. All right. So there it is. It's some memory address, right? And it's just like if you have, let's say, I declare a variable int x, right? And I don't give it a value, and I do a cout x equals x and l. Okay. If I run this thing, don't be a 0. It's a 1. Okay. So let's find another one. Int z. Cout z equals z. Just check again. There you go. Finally you got it. Oh, and the x changed too. Notice how the value of x, even though I haven't given a value for x initially, it was 1 just when I ran the program right now. Now it changed to some other. The value of z is like 154871. What are these numbers? Why are these variables equal to these numbers? Because C++, okay, so when we declare a variable, right? Right, so if I have a variable, this is my variable name, this is what is in memory, right? And this is the memory address, right? So if I declare a variable x, right, I'm giving it some kind of a memory address. I'm just going to pick one of these. Who cares? There, something like that, right? And then maybe there was a value of 1 in there stored already from some other program or maybe this program. Okay? Can't help myself. Okay? But then when I run the program again, this memory address here is going to change to something else, maybe like 5F. Okay, but what's stored in 5F is this weird number. And again, it was stored from some other program or whatever. It's just some number that's stored in memory. It could be an instruction from another program. Okay, so that's why if you have a variable and if you have not specifically initialized this to be like a 0 or something, you can expect any kind of a garbage number to be in there. and you can see that the variable z is like, some other weird number. Okay, so let's say this is the z. All right, it's some other huge crazy number in there. I call these garbage numbers. Okay, so similarly, when I have a variable a, big variable a, right? I'm just saying, okay, well, there's going to be a big variable a. It is going to be a pointer variable, right? I'm going to put like a little comment next to it, pointer. And initially, there is, instead of a garbage, well, it is a garbage. It's one of these garbage numbers in there. But the garbage number that is stored in the variable a, because it is a pointer, it's a memory address. Because that's what this variable is going to be equal to. Okay, we're going to overwrite this content just like we overrode this crazy number to like 99 or something. We're going to override this number for the pointer variable to an actual memory address of some other variable. Okay, but for now it is garbage. Okay, that's what this number here is. It's just some garbage memory address that's just left in there. Question?
Yeah, your pointer variable a has not been initialized. So are you allowed to go and it's pointing to some random location in memory? Are you allowed to go modify that random location in memory, or is that not allowed?
You mean, are you allowed to give this thing an initial value?
No. Without it being initialized, it's pointing to some random location in memory which could belong to.
Can you specify what that random location in memory is going to be? No.
But say it belongs to this memory space in another program, and then you go and try.
No, it's not going to go. It's not going to be a memory space of another program. It's going to be a memory space of available thing, something that's not being used.
Even though it hasn't been initialized.
Yes. Yeah. So these variables, when we declare these variables, we are not going to place them in memory of like where Microsoft Word is running, because Microsoft Word is holding up that chunk of memory. It's going to be placed somewhere that's available in memory, that is not being used by any of these other programs. And by the way, this kind of leads to an interesting or important thing, which is the memory leaks. What is a memory leak? Well, if you keep declaring pointers in C++, you're going to keep grabbing pieces of memory for your pointer variables. And if you never really delete those pointer variables, your program is going to hold those places in memories for as long as the program is running. And if you have some kind of an algorithm or a loop or something that keeps creating new and new pointer variables, you're actually going to end up sucking up all the system memory, and things are going to crash, or the operating system is just going to kill the program. Okay, that's called memory leak. Okay, memory leak is basically creating a whole bunch of these pointer variables which occupy the empty space until there's no more empty space, and then just things are not working. Okay.
What would you have to make for that to happen, though?
What's that?
How many pointers would you have to make for that to happen?
Millions.
Oh, okay.
Yeah.
Just if it's a
Yeah, millions and millions. In fact, in my data structures class, I have an assignment where I ask the students to calculate exactly that. Like basically make a program that creates a whole bunch of these and tell me when it crashes. It takes a long time, okay? Because you have millions of memory addresses. I mean, look at this thing here. That's a big number. That's a big hexadecimal number. That's how many slots in memory are in, that you need to exhaust before the program runs out of memory. Okay? So anyway, so that's the good question, right? Now we know what memory leak is, right? You capture memory and you never release it using your pointers. So we're going to have to delete pointers if you wanted to do that. We're not going to worry about this for now, because let's just get the hang of pointers first before we know like memory leaks and all that other fancy stuff. Okay, so again, what is my A equal to? My A here is equal to this, which is just some garbage memory address, right? And then the other illustration here that I showed you was, this is, right? Garbage memory address. Okay, and just that was the example of these other ones here, is that this was equal to this, right? X is equal to this, and this was an example of basically a garbage integer, right? Stored in memory. Okay, and similar to that, you had your Z here, which is equal to, again, some garbage number. And why is this again, I explained why there's a garbage number. All right, it's just basically what was left in memory before you actually gave this thing a specific value. Okay, so now we know this. I'm just going to take these out. Okay, so we know A, right? Big A is equal to this. And then little a, let me copy this. So little a here, the memory address of little a, %A is equal to this. Right? So you can see that this one here is different than that one, obviously. Right? Maybe you can't see it. So in that case, it won't be obvious. Let me increase the font size. All right? So you see this thing here, this is a completely different number than this one. Okay? Let me see if it changes when I run the program. I run it again. And little a actually changed. Alright, that's what I was telling you. If you keep running the program like run, the memory address is not going to change much or not at all. But if you wait a little bit longer, things are going to move around in memory. That empty space is probably not going to be empty anymore, so you're going to have to find a different place where you can take for your variable. And that's why the memory address of the variable is going to change. So it changed here. And then the one on the bottom also changed, right? So big A also changed. All right? And this is the you know, that's, I guess, an illustration of why you want to use variables, right? Because you can't rely on some specific memory address to always be the same, just like you're not always rely on some IP address on the internet to be the same. Like Google is not always going to have the same IP address, right? But if you remember google.com, there's a mechanism, DNS servers and all that good stuff, that will allow you to go to the Google's IP address without specifying the IP address. Anyway, so now the next thing that I'm going to do is I'm going to make A equal to %A. Okay? So now what I'm doing here is, so I'm make A pointer equal to the memory address of little a. Little a, right? So that's what I just did here. And now let me show you A one more time so that we can see if it's actually storing that value. So I'll run again. All right. So big A here, when I run the program here, this time they changed again. So this is my little a's memory address. This was the uninitialized value of big A. That's a nice number. And then when I did this, now it's equal to this, right? And you will notice that this is the same as this one. Okay? So this is the same address as little a. Okay, so at this point now, right? At this point, or let's just say now big A points to little a. Yes? All right. So now, what's the point of all this crap? Well, I can actually change the variable little a using the variable big A. Okay, and this is just one of many applications of pointers, by the way. And you need to understand pointers because we're going to be using pointers for pretty much everything in the data structures class. Okay, I'm not going to get fancy. I'm not going to go crazy with pointers. They can get obnoxious, right? There's left pointers, there's right pointers, there's pass by pointer, there's pass by reference. There's like 50 different ways to do the same thing in C++. I'm just keeping it basic. So the next thing I'm going to do is I'm going to show you how I can change little a using big A. Okay, so I'm going to change this value without using variable a at all. So I'm going to go in there. I'm going to say, okay, well, asterisk a is equal to 100. And then if I do cout here of little a, in fact, why don't I copy this thing here? All right, so this one, first of all, this one here showed you a is equal to 1. That stays the same. And this one here, hopefully, it will show you a is equal to 100. Okay, run it. And yeah, a is equal to 100. Okay, that is how pointers work. Any questions? The little asterisk is called the dereference operator. Okay, so this is how we're changing. So this here changes the value of little a. Okay, and I can only do that after I have pointed a to little a. Questions?
Can you also change the memory address or just the variables?
Can I change the memory address of a? No. A stays in this memory address, whatever it was initially. Yeah. So yeah, I cannot change the memory address of a. I can only change the value that is stored in that memory address, right? So I'm changing, if this is my little a, I'm changing this here. I cannot change the memory address of a. Okay? Only this. I can change the memory address of the pointer a, right? If I wanted to repoint a to another variable, I can have another variable here, int b, right, is equal to 100. And then as soon as I do this, I can say, okay, well, a is equal to ampersand b, right? And I can say asterisk a is equal to 1. And then I can show you cout b equals, or little b equals. And what is little b going to be equal to here?
1.
Okay, good. All right, hopefully. Run it. Yeah, it's 1. Okay. So, got how pointers work? Any other questions? Okay, I like questions. Keep them coming. So, now that we know how pointers are working, what I'm going to do is I am going to use them in a function. Okay, so I said this is going to be a function called pass by pointer. Okay, and I'm going to declare a variable, which is going to be a variable d, which is going to point to an integer. Okay, and then what I'm going to do is I'm going to change my parameter from inside of the function. So let's say, remember this piece here? Let me just cut this, and I'm going to put it after. There. Okay. There you go. All right. So remember, we had a b is equal to 99. You show the memory address of b. Then I show you that yeah, there's 99. Pass by value. You're trying to change the b in there, right? But when you show the b in the main, it doesn't change. Okay. So what I'm going to do is get this out of there and put it here. There we go. No, not there. Sorry, right here. Okay. So next thing is, let me grab my pass by pointer, make a definition. All right. This is my pass by value. Here's my pass by pointer. And then here, what I'm going to do is, I'm going to do the same thing that I did in here. So I'm going to say asterisk d is equal to, what do I want to change this to? 0. Okay? And then what I'm going to do is, I'm going to do pass by pointer. And when I call this, I'm going to do ampersand b. So I'm going to send the memory address of b. So as soon as I do this, right, as soon as I do this, pointer d becomes equal to the memory address of b. Right? So this is make pointer d equal to the memory address of b. Okay? I'm glad I picked different variable names. And then if I do this here now, what is the value of b going to be? Hopefully 0. Okay? Keep your fingers crossed. And yeah, there you go. It's a 0. Okay, so this is how you can change the value of a parameter from the value of a local variable, right, which is the parameter, from another function. Okay, so we're sending the memory address of b into the function of called pass by pointer, and then we're changing the value of b from inside there using a pointer. Okay? So maybe you're going to ask, well, what's the point of this? Why would I want to do this? Well, maybe you have some kind of an input function, right? Maybe you want all your input to be inside of a function, right? Let's say I have int num1, num2, right? And then I want to have a function which is going to let the user enter the values of num1 and num2. So I do something like input, and then I say, all right, ampersand num1, ampersand num2, right? And I'm going to declare my input, all right? Void input, and I'm going to say int asterisk, int another asterisk. And by the way, the actual variable names, you don't really need to have variable names for the pointers, but I'll have them. Let's say this is going to be n1, n2, right? Then I'm going to do my definition. And I'm going to do something like cout, enter first value, right? Cn, and then I'm going to do asterisk n1, and I'm going to do the same thing for the other one. Second value, this is n2, okay? So I'm going to go call this function, I'm going to ask the user to enter the values, and then I'm going to show you cout num1 equals, oops, num1 and del, and this is your num2. Alright, maybe I should have done this before also, so you can see them before and after. So I run it, num1, num2, they're both 0 fortunately for now. Okay, enter first value 10, second value 20, and now num1 and num2 become equal to 10 and 20. Okay? Any questions? So now you know, pointers. Okay? Alright, pointers. And don't worry, I'll show you more of that stuff. Alright, so going to week 7. Yeah, so I guess I'll just go through these different assignments, 39 through all of it, and give you some hints. Alright, so first one is we have number 6 is truly a great number. Given two integer values a and b, write a function that returns the string great if either value is 6. The function also returns great if the sum or the difference of the values is 6. The function returns not great otherwise. Okay? Anyone want hints on this? Yes? Okay, for Rigo. Alright, so 39. So these are your hints. This is P39. Okay, so this was string great, right? And it takes int A, int B. Okay. And I'm gonna throw that in here. These are your hints. P39. There you go. All right. So it goes like this, right? So if either one is 6, right? So if A is equal to 6, or B is equal to 6, or what is it? A plus B, right? Let's go. A minus B, right, is equal to 6, and you can also have or B minus A, right, is equal to 6. Then this thing returns great, right? And of course, yeah, but I'm not putting the whole solution in there. So yeah, you have one more thing in there. Okay, so I'll erase this too. Right? So more things you need to check, right? So if it's A is equal to 6, or B is equal to 6, or A minus B is equal to 6, or B minus A is equal to 6, or A plus B is equal to 6, then it would be a great. And otherwise, you can just say return not great. And that's it, right? Not complicated at all. Okay, so this is your P39. And then you have a couple of, I give you the main, use these calls so that you see if it works. And the expected output should be this. 40, given two integer values, return true if one is negative and one is positive. Except if the parameter negative is true, then return true only if both are negative. Right? So, P30, P40. Alright. You have boolean, bool, pos, neg, and you have int value 1, int value 2, you have bool, negative, right? And then in here, so it goes like this. So return true if one is negative, one is positive, except if the parameter negative is true, then return true only if both are negative. Okay, so I'll start with this one. So I'm going to say, okay, if my negative is equal to true, right? And if if both are negative, and v1 is less than 0, and v2 is less than 0, then I'm going to return true. Okay? Lowercase true. Alright? And then it's complaining here that I can simplify this. So instead of doing it negative equals true, I can say if negative. Because negative is either going to be true or false. I don't have to say equals true. But it will be either equal to true or false. Alright? So that's that. But let me change it back to what it was. Alright? Hopefully it makes more sense. So that's one. And then except, and then given two int values, return true if one is negative or the other is positive. So and after this, I will just do an else. Right? And then now you have to check to see if one is negative and one is positive. So it's basically if v1 is less than 0 and v2 is greater than 0. Right? That will be also return true. Right? And then you would have another one. Right? And then again, you have to do a return false. Okay? So basically you exhaust every possible case where it could return true, and if it's not any of these, which is where the program would exit the function, then when you get all the way to the end, you just return false. Okay? So that's your 40. Next one, 41. Given three integer values, return their sum. However, if one of the values is the same as another one of the values, it does not count towards the sum. Okay? So, this is your P40 1. Alright, so this one is int lone sum, and I have three different variables. And A, and B, and C. Right? And it goes something like this. So you have to write a few of these. Right? So it's basically, if two of the values are the same, you don't count the sum. So it's basically, alright, if you have, and then what you have to consider is that there's different ways in which we can call these functions. So what I'm trying to say is you should call it with, say 1, 2, 3, right? So that they're all different. Then what you should do is you should call it with like a 1, 1, 3, right? The first two are different. You should call it with 1, 3, 1, right? The first and the last are different. You could call it with 1, the last two, 3, 1, 1, right? So there's actually more than just these test cases that you see here. Okay, and what you should do is you should test your program for every possible one of them. Okay, so the way I would recommend doing this is imagine how you could call this function with the different kinds of values that you could call them. right? So this one is if they're all different, right? Right? So this is all different. But then this one here is when A is equal to B, but B is not equal to any of these. So let me go with this one, right? This one is if my A is equal to B and my B is not equal to C, right? That's that one. And if that's the case, what am I going to return? Return. What am I returning in this case? I'm returning which value? So if these two are the same, they don't count. I'm going to be returning this, right? So I'm going to be returning C, right? And do the other ifs also, right? Do more ifs. Oh, and by the way, there's another case where they could all be the same, right? You could also have 1, 1, 1, right? So in this case, and again, you basically tell yourself, okay, this one here returns 3, right? This one here also returns 3, right? Returns 3, right? So this one here, all different, should returns 6, right? This one also returns 3. This one here returns 0. So as you can see, there's 1, 2, 3, 4, 5 different ways this function can go. I showed you one of them. Okay, so you got to do more ifs so that basically you handle these other cases when they're all different, when the first and the last are the same, when the second and the last are the same, when all of them are the same. Okay, questions? Okay, next one. This is 41. 42. Write the definition of a function that returns a random number based on 2 arguments, min and max. Right? So this is something that already exists in the Python language, and you get to reinvent the wheel for C++. Right? The random function, which you take for granted, you get to write it now. Okay? Any questions on this one? Anyone want me to do a hint on this one? Going once? Going twice? 3 times? Or 2.5? 2.6?
Sure, let's take a hint.
All right, let's do a hint. So we're gonna do what's this one? 42. Okay. P42. It's going to be an int, rand int. All right. It's going to have a min, int max. Okay. Now to make the random number, what I would recommend is don't put all the code in here. Okay, so what I'm saying is we're going to go to the main. This is your P42. P42. And by the way, notice one thing. All these functions, a lot of these functions that I'm writing, because they're not calling each other in any particular order, I am not putting the prototypes in there. But you're supposed to. Right? You are going to put prototypes for every one of the functions. Okay? Otherwise, you're going to find yourself losing some points. So, P42. 42, where are you? Okay, yeah. So, what I was going to do is, I'm going to do that random number business thing first here. So, I'm going to do int IC is equal to time null. Whoops. Right? And then I do srand iseed. So I have to do this first, right? Do this here, and then we're going to do the rest of the random business inside of the function. Okay? And then this was basically just random. I can just say return, and what I'm going to return is min plus rand, and then how did it go? Remember? Max minus min plus 1. And that's it. Alright, that's it. I solved it for you, unfortunately. Semicolons at the end. There. You can probably get rid of the semicolon. Yeah, let's leave it there. not semicolon, parentheses. Okay, so there you go. Now you have a function that returns a random number between min and max. And guess what? If at any point in the class, any assignment tells you, make a random number between whatever and whatever, use your random function. Copy paste. Okay, not that hard. Okay, for the final project, you're gonna have to make a random number. I'm actually literally gonna tell you, use this random function to make yourself the random number. Question?
Yeah, you put that code for the IC in main. What's the difference putting it in main and putting it here? Because I did that and it was different.
It was different.
When I
It
put
doesn't really
that-
make the random numbers the right way when they're in the function.
Yeah, it wasn't random.
It wasn't random.
And so then when we did
Yeah,
that-
what happens is, what was the explanation? I actually came up with an explanation for this thing. When you run the program here, you're pulling the system time one time. I think what happens was if you put, oh, okay, there you go. So what happens is it uses, if you put this code inside of the function, it will be basically, let's say if I do this. Here's the example. Here's why it's not working. Okay. So suppose I have function here. I'm going to have int random num is equal to let's say just rand modulus 3, right? So this is going to make me a random number 0, 1, 2, correct? Okay. Now, if I was to do this, I do an srand here. So remember, when I do an srand, you get a bunch of big number, big number, big number, big number, right? It generates a list of random, pseudo-random numbers, right? If I do int random, and let's say this is not IC, this is 0, right? It's 0. So if I say 0, srand 0, it will always make me these random numbers in this particular order, right? And then I can use the modulus 3 on each of these, so that this one is going to come out to be 0, and then etc., 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 right? Now if I do this, so as soon as I say srand, so this rand is going to pull this number from the list, right? Now, if I do the same thing again, I grab this and I put it here again, and I happen to do this thing again here. There. What it will do is this again is going to generate the same list of random numbers, right? And this thing here is going to pull that same first random number. You see? Does that make sense? Okay, so every time, if I do srand 0, and then I do rand modulus 3, it will pull that first number, and it will basically give me the 0, because this number modulus 3 is a 0. Okay, if I do an srand again, it will reset the rand so that it will go back to the beginning of this, and it will pull again the same number, and then it will turn out to be a 0. Okay, that's what's happening when you put these two lines of code. Damn it, I erased them. Here, srand IC, right? When you put this inside of the function, or if you put this code inside of the function, what happens is IC is going to stay the same, because IC is the system time when you run the program, right? And that means that this is going to stay with the same number, right? Basically the same thing as having a 0. But since if you have this code inside of your function, if you have this first and then you try to make a random number, then it will grab that first number. And then as soon as you call the function again, you will do this again and it will grab that first number again. Which is why we want to have this one time only, which is right here, and then every time you do rand, now rand is going to pull the next number, which is what you want. Did that explain things? I hope. Okay? But the bottom line is you want this here, all right? not in the other one. Okay. All right. So yeah, that's why. Good question. I was actually confused by it too. It took me a little while to kind of digest what kind of what's happening.
Okay, so the scope discussion that we had before, I thought it should have been in the function. Because the scope-
You would no, but that's exactly what's happening though. Yeah, when you have these two lines in the function, then what's happening is you're setting srand to be equal to that first to the same number every time. So when you make a random number, it always pulls that first number, right? And that's why you don't want to have it. Okay, so this is why you don't want to have srand inside of the function. Okay? All right, because if I can spell it, because if you do, calling rand will always pull the same first number in this case from the list of random numbers that srand generates. Right? And this is the list of random numbers. List of random numbers. Okay? And then remember, this list of random numbers will always be the same for the same value of srand. Okay? The only way for me to change this list of random numbers is if I feed this thing a different time, system time every time. All right, so this is your 42. Right? Good questions. 43. Oops, sleep in. I kind of did this one already for you, but this one is slightly different. So you have a function, sleep in, with two parameters, weekday and vacation. Right? The parameter weekday is true if it is a weekday. The parameter vacation is true if you're on vacation, and you get to sleep in if it's not a weekday or we're not on vacation, or we are on vacation. Sorry, it's not a weekday. Right? So if it's a weekend and we're on vacation, or we're on vacation. All right, so it goes like this. And this is a Boolean, right? This is your prototype. I should change this thing to a semicolon. I got lazy. Copy pasting things from the Python class. Okay, so this is 43. P43, paste. All right, so if it is a weekday, right, you can, no, if it's not a weekday, right, you can sleep in. All right, so return true. If it is a vacation, right, you can sleep in, return true. Okay, and I guess you could say an else if. All right, else if. Okay, if it's not a weekday, you can sleep. If it is a vacation, you can sleep. Right, and then there's a few other ones in there. So I guess the default, return false. They're not hard. Okay, but you have to use your logic. And again, don't look at my hands unless you absolutely have to. Okay, ignore all this stuff until you like absolutely hit a wall and you can't figure it out. Then have a peek and then close it real quick so that it doesn't remain in memory. Okay, if possible. So this is your P43, and I have like a couple of different calls. What it's supposed to be like, right? Test all of them. Okay. Monkey trouble. All right. We have two monkeys, A and B, and the parameters smile, A smile, and B smile indicates if each is smiling. We're in trouble if they're both smiling or if neither of them is smiling. Anyone want hints on this one? Yes? All right. I'm looking at Rigo because he's the brave one. All right. All right, so if they're both smiling or not smiling, you're in trouble, right? So I guess this is, let me copy this thing. All right, so if A smile and B smile, then you return true, right? And then a few more ifs. You do the rest. That was your hint. A few more ifs for return true and return false. Okay, 44. How many more do I have left? All right, let's see. And as you can see, we're at week 7. We're already at assignment 47. So you better be keeping up. Okay, 44. Sum double. Last one that's not extra credit. I guess I'm gonna have to teach you prime numbers and the stars in 10 minutes. See if I can do that. I can do it. Given two int values, return their sum unless the two values are the same. Then return double their sum. That's easy. Anyone want hints? Any nods downward? By the way, do you know what's unique about Bulgarians? We're backwards. So this is yes and this is no. I'm not making it up. Yeah. Find another country that's backwards like that. Okay, it takes a while because when you go there and everybody's like looking at you, you have to do like the side shake so you don't confuse people. Like, all right, so anyway, so nobody wants it. We got it? All right, good. So the next one, 45. So yeah, that's easy enough. All right, next one is prime numbers. How much information do I have on prime numbers? Not a whole lot. All right, so there you go. Write a function that finds and prints all prime numbers between 3 to 100. A prime number is a number that can be evenly divided only by 1 in itself. One way to solve this is to use a doubly nested loop. The outer loop can iterate blah, 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 blah. Okay, so let's go back to the prime numbers here if I have any clues to show you. No, that's not very useful. All right, here, what the hell, I'll show you. So let's say, for example, the idea is to go through the numbers between 3 and 100 and figure out what's prime and what isn't prime. The way you're going to test to see if a number is prime, let's say, for example, we're talking about the number 6. Okay? So what we're going to try to do is we're going to try to divide 6 by 2, by 3, by 4, by 5. So you're going to try to divide this thing from 2 to 1 less than itself. And if it is not evenly divisible by any of these numbers, then it happens to be a prime number. So the test for this will be, right, is n, if n is 6, modulus 2 equal to, what is it equal to? Is n modulus 3 equal to what? N modulus 4, what is that equal to? N modulus 5, what is that equal to? If any of these happens to be equal to 0, it's evenly divisible, so that's not a prime number. Okay? And if, for example, let's say, for example, where you're looking at number 5. For the number 5, which is a prime number, you're going to test, is 5 divisible by 2? No, it's 2.5. Is 5 divisible by 3? No. Is 5 divisible by 4? No. You don't get a remainder 0 for any of them. And since you can divide 5, you cannot divide 5 by any number between 2 to 1 less than itself, which is the 4, then it is a prime number. That's the test. Okay? So the way you would do this is you would start with the inner loop, right? So first you're going to come up with some number like 5, right? Then make a loop that goes and generates these numbers 2, 3, 4. Then throw in an if in there to see if any of these numbers are evenly divisible, right? And then if you go all the way to the end of the loop and it is not evenly divisible, then you show the number. That's your prime number. Okay? That's as much of a hint I'll give for that one. If you need more, I'll go over it next time. And then the other one is the stars. right? And it basically is two nested loops, right? You're going to have one loop that generates the numbers from 3 to 100, and there's going to be another loop that goes and generates these other numbers that we're going to try to divide the first number by. Okay? Ignore the first one. So you're not going to try to solve the whole thing at once. Just start with something simple like the number 5. Then make another loop, make a loop that generates the numbers from 2 to 1 less than 5, right? Then see if any of these numbers can divide that number 5. And then if they don't, show it as a prime number. Then manually go and change the number 5 to like 6. Test again. Does it work for 6? If it does, then make a loop that goes from 3 all the way to 100 and see if it shows you all the prime numbers. Alright, so then last one is the stars. Okay, so the stars is supposed to work like this. Alright, so you're supposed to show as many stars as the number that the user types in. So if the user types in 5, you do 1, 2, 3, 4, 5 rows of stars, and each row the stars increase by +1. So when you go to the 5th row, there's actually 5 stars. Okay? How are you going to do this? You're going to use nested loops again, right? And then let me add a little restrictions in here so that I make your life more difficult. You're not allowed to use string concatenation. You are not permitted to use string concatenation. Okay? So if you find yourself solving this problem with a single loop, you're not going to get any points. So you have to use one loop inside of another loop. And let me explain to you how that should work. Just give you an idea, since it's an extra credit, I'm not going to give you the hint. Maybe next time. I'll do that next time for the lecture for the midterm. How's that? Okay? 'Cause I'm running out of time today. So the way it's going to work is you're going to make a loop that's going to, first step is make a loop that is going to show, like say if the user types 5, you show just these first ones. Right? So you're going to show, if the user types 5, you show 5 rows. Each row has a single star. You're not going to do this yet. Okay? Then what you're going to do is you're going to realize that, hold on, the actual relationship of how many extra stars we add is, if we call this row 0, we're adding 0 stars. If we call this row 1, we add 1 star. Row 2, 2 stars. Row 3, 3 stars. Row 4, we add 4 extra stars. So now in addition to the first loop, which made these first stars, you're going to make another loop which depends on the first loop. So if the value for the first loop, if you're going through the first loop for the first time, that's line 0, so you're adding 0 stars. If you're going through the loop for the second time, you're going to add 1 star. Third time, 2 stars. Right? So how many times the inner loop is going to happen, it depends on the outer loop. Okay? Any questions? Fantastic. So prime numbers, stars, and a bunch of functions to keep you entertained. And we also have a quiz at the end. Chapter 4, Savage. It's in one of the previous weeks. Look for it. And again, it's with any other quiz that I have, except the midterm, you can take this multiple times. Midterm, you can't. All right, so make it count. The midterm is going to have a multiple choice too, right? Not multiple attempts for that one. Unless you, like, really, well, I don't want to say unless, right? Just make it, let's make it one attempt. Okay? All right, so with that being said, that's all I have for today. You know the drill. Come see me in the office hours. Send me your emails. Whatever you got to do to let me know to